Okay, we're going to proceed on with wind and weather here a little bit. Really, we're going to mainly talk about wind. So we've learned about pressure just recently here, and the driving force of wind is pressure change, pressure gradient, in other words. So that is what really is one of the main driving forces of wind. So let's see if we can go on from here then. So what is wind? Well, if you're outside, you feel air hitting your face or pushing you from behind. That's wind. It's a push or pull on an object. It hits it, causes it to move. Oh yeah, one thing about wind that's different than all other meteorological variables we're going to talk about is it is a vector, which means it has both a direction and a magnitude or speed. So if you were driving a car and you were driving along a road, believe it or not, you have a vector quantity. You are either driving to the north, you're driving to the west, and you have a speed, 55 mile an hour, 75 mile an hour, whatever. The same with wind. It has both that direction and a speed. So forces are what make the wind move. We're going to talk about what those forces are that cause wind. So we talked about pressure gradient being important. Well, here is a map of pressure gradient looking to the north on both of these. Notice how the top one, the lines are fairly tight together and the gradient in a relatively 1,000 miles, maybe 8 millibars or so, while below, they're actually 12 millibars, and below they're spread out more. The closer your isobars are together, the stronger the wind's going to be. So in a high pressure system, the isobars are kind of wide apart. They're not very close, so the winds are going to be lighter typically in towards the middle of a high pressure. However, towards the middle of a low, pressure gradient actually intensifies as you get closer and closer to the low. So the pressure gradient increases, your winds are going to be stronger the closer to the low you are. One other thing that controls this, the centripetal force. So you're going around a curve in a car. Your car doesn't go off the road, it just goes right along around the curve. Well, the force that's keeping you on that curve path is centripetal force. So it's a center-seeking force. It holds. Same with wind. It helps it to go in a circle. And it's not an independent force. In other words, if you don't have that little string holding on that ball there, that ball's going to just go flying out somewhere. It needs to be the object going in a curved motion. And it rises from an imbalance of forces, so the forces are never equal there. Another force, only on a rotating Earth can you get this one. And the Earth rotates, is the Coriolis effect. So think about it. How far do you move if you're in Alaska compared to how far do you move in 1 hour if you're in the middle of the United States? Okay, up in Alaska, you're only about 30 degrees from the North Pole. North Pole doesn't move. It just sits there. So the rotation means that Alaska has so far you move, but not necessarily real far. Closer and closer to the equator you get, the further and further you're going to move. That's why there's a force. This Coriolis effect moves the wind to the right in the northern hemisphere. In the southern hemisphere, it moves it to the left. But in the northern hemisphere, it moves it to the right. And here you can see that deflection is more and more the further north you get, less and less deflection at the equator. Friction is the next one. It only occurs down near the surface of the Earth. Basically, above about 1,000 meters up or so, you're not going to get a whole lot of friction. You're going to get some days. Turbulence is another part of fluid flow. I had it described to me once, pouring creamer into a cup of coffee. You see it just go everywhere. That's turbulence. That's why it's so hard to mathematically formulate, but it does occur in any fluid, and the atmosphere is a fluid. So turbulence occurs in every level of the atmosphere. So there is an aspect of friction, but friction is much stronger down towards the Earth's surface. Gravity is another force. It's pulling everything downward. It only acts in one direction, down towards the Earth. And it's made up of two parts because we have a rotating Earth. You have gravity that's pulling down between the objects, and you have centripetal force, which is much weaker, holding it to as well. So there actually are two parts to gravity on the Earth's surface because of rotation. So now we start bringing these features together. So horizontal pressure gradient force initiates the air motion. Then centripetal force can act to turn it in a circle. Coriolis effect turns it to the right. Friction will slow down the wind because it always acts in the opposite direction of the wind. And gravity will push the air down towards the surface. So let's start with, think about it. There is a tremendous pressure gradient in the vertical. We've talked about the pressure decreasing with height fairly quickly. So there is a tremendous pressure gradient in the vertical, but gravity is pulling that down and they're in balance. So that an air parcel through the hydrostatic equilibrium is right in balance. It's not leaving the Earth, but by the same token, it's not settling down to the ground. Now, say that air parcel encountered a mountain. It would begin to move up the mountain. Say it come down the other side. It might continue to go down the other side, but it's never accelerating. That's what's key to hydrostatic equilibrium. It says the air parcel can move up or down, but it just can't accelerate. Geostrophic wind. It's two components now. We're going to deal with the Coriolis effect and the pressure gradient. So the pressure gradient acts directly across towards lowest pressure because the atmosphere hates low pressure. It wants everybody to be equal. And eventually it's a balance between the pressure gradient pushing towards the low pressure and the Coriolis effect keeping it to the right. And basically it is a straight wind along isobars. In other words, here you can see the 608 and the 612. It's just moving parallel to those isobars. Typically occurs in the upper part of the atmosphere. We'll look at it here in a little bit. Here is the gradient wind now. The gradient wind as centripetal force. It goes in a curved motion around highs or around lows. So you see the curved is an imbalance of forces, but it causes a curvature and lows. Friction only acts down in the lowest part of the Earth. It's the biggest component of it. And think about it. If the Earth is very rough, like mountains or a lot of little tiny hills, friction is going to be a lot more than, say, over a lake with hardly any causes for friction there. So it always is opposite too. So if you have the wind direction you came up with here, say the wind direction was that way, here would be your friction, always acting against that. And because of that, the Coriolis effect is going to be diminished because Coriolis effect depends only on the speed of the wind. So it's going to be a little less. So what happens is it allows the wind to turn more towards the center of a low and away from a high. So since the Coriolis force is weaker, but the pressure gradient force is still the same, this wind will move towards low or away from high. So that's why in the center of a low pressure system, the winds rotate inward. And the center of a high pressure station, they rotate outward. All right, we talked about the continuity of air a little bit with pressure. Same principle holds here. If you have horizontal convergence aloft, winds pushing together, say you have faster winds hitting slower winds, then your air is going to tend to sink down towards the ground. Guess what? It can't hit the ground and go into it, so it's going to spread out. You're going to get horizontal divergence. The opposite effect, say you have divergence aloft, your wind's going to tend to want to rise up, fill in that space up above you. What happens is the air down below is going to have been lifted, and the air is going to want to come into where that lifting has occurred. So you're actually going to get low pressure there and winds moving towards the low pressure. That's how low pressure is formed because of that divergence aloft. Begins the process. Mountains can accelerate winds up and down. Again, with the continuity of winds here, And we talk a little bit here on planetary scale motion. We're going to get more into that in the next chapter. And so I just wanted to show you just a couple examples of the wind. Here is a low pressure over Lake Erie, Lake Superior. Notice the winds blowing counterclockwise around it, and notice them blowing in, cutting across the isobars towards the center of low pressure. Also notice the winds are stronger over the water than over the land. Only 5 knots here, 15 knots here. So you can see the effect of friction here, and you can see the impact of the gradient wind right here. This is a description with gradient wind with friction. So if we wanted to look aloft, way up in the atmosphere, here's 300 millibars. There's a strong jet stream across this area right now. The strongest winds are 85 knots here, 85 knots there. Looks like 95 knots here, so pretty strong jet all the way across here. There's 90 knots right in here. So there's good divergence probably up in this area, left front quadrant of the jet, and the right rear quadrant will have the other area of divergence, which will be back here, which is where there's a real good complex of thunderstorms right now. But you can also see some gradient wind at this level, like over a high pressure system right here, another high pressure system right here, and here's a curvature. So you go from geostrophic to gradient. And finally, here's a real good picture of 500 millibars halfway up. Here's your gradient winds. Here's your geostrophic winds following the map. So this is just an example of your wind fields. I hope you get something out of this. You understand a little bit about the complexity of forces here and how they can move those air parcels that you see all around the world. So let me know if you have any questions with this.